Let's now see how to view and review the exams acquired with the keratome. Within the software, we will have a list of the entire database, and we can search for the patient by date, in chronological order, in alphabetical order, by operator if needed, or even if I select filters by issue or pathology. By double-clicking on the exam, I can view the individual images acquired. The one with the flag is not the best topography. It's simply the first one processed for that eye. In this case, we have 4 topographies of the right eye. If we had performed additional topographies for the left eye, number 5 would also have the flag. By double-clicking on the map, the software interface opens up directly to display the detailed topography, and the fully processed image of each of the individual rings, which clearly highlights the position of the pupil. Once we have reached this specific point in the process, we are able to focus our attention by significantly enlarging the topography view and carefully examine the various numerical parameters that the software provides for our analysis. The upper section concerns the values of the mouse pointer, meaning that whenever I press and click with the mouse on a point on the topography, I will get the values in terms of power, radius, distance, meridian, and height for that specific point. Obviously, it starts from distance 0 and height 0, because the reference point is the center. So if I position the mouse and click in this area, the values will change accordingly. In the section with the keratometric values, we have the values in diopters and millimeters for the 2 meridians, the steepest and the flattest, as well as the average and the difference. We have an assessment of the Maloney best fit, which is a classification widely used to evaluate the quality of the cornea, the eccentricity at 8 millimeters on the steepest meridian and on the flattest meridian, and the corneal diameter. The corneal diameter also allows for the localization of the center of the pupil. Below here, instead, we have the keratoconus screening. The software will automatically evaluate any areas with a curvature much higher than the average of the cornea. And it will give me an indication with a green, yellow, or red traffic light. The higher the incidence of a possible keratoconus in percentage, the more the traffic light will change from green to yellow and then to red. This keratoconus screening function is also very useful for evaluating any corneal changes before and after application. It should not be considered exclusively for keratoconus, but also as an indicator of corneal variation. Why? Because if I take a topography today, then fit a contact lens, and take another topography after applying the contact lens, if these parameters, in terms of diopters and the incidence of any corneal change increase, it means I am modifying and creating some change in the cornea. The question then is, was this change expected, corneal or not? Clearly, if we're talking about orthokeratology, it's normal to induce a corneal change. But if we're considering the topography of a standard routine lens fitting, these values need to be taken into account, even for evaluating the lens fitting itself. Next, from the panel at the top, we can modify and change the type of map we are evaluating. The first one that opens is the instantaneous tangential elevation curvature map. We can call it whatever we like. After that, we will have the option to view the axial map, highlighted here, the Gaussian map, and the spherical subtraction map. Here, we can select an ideal sphere and then evaluate the topography by subtracting the value of this ideal sphere. Additionally, by simply right-clicking directly on the map itself, we can also choose to go to spherical offset and choose a different reference for the spherical subtraction. If I don't select anything, it suggests the best fit, or I can choose to be tangent to the vertex at 3 points or tangent at 1 point. Finally, we also have the wavefront section for aberrations. So by pressing the W key, the entire aberration section will appear, obviously corneal aberrations. Because since this is a topographer, we cannot evaluate the posterior surface of the cornea or the internal aberrations. Here we have the map of the wavefront refraction, where we can also evaluate a PSF, that is a point spread function, which means what that eye sees in the dark. Visually, with those aberrations, we can simulate visual acuity, again with those aberrations, and go on to evaluate, also providing a summary, the various low and high order aberrations, always at the corneal level of that eye. It is quite obvious that we are also able to perform an evaluation of a significantly different size of the pupil, which will, as a direct consequence, modify the specific numerical value of the optical aberration. Next, we have additional buttons and functions. The most important are the print function, which we find in this part of the screen, and the differential map, which is the ability to have multiple topographies of the same eye open, taken on different dates or pages, and to perform a subtraction, a difference between the two maps. In other words, taking the first map and subtracting the second. Finally, we also have the 3D profile panel, which allows us to view, for a given map, if we have opened the spherical subtraction, the actual 3D profile of the cornea itself. Lastly, before considering the option to change the type of scale, we have a variety of extra buttons which can be specifically tailored and configured to work in perfect harmony with the interface of your external contact lens software.